Hello! Having touched the subject of row and file formats, we spoke about row formats only. You likely remember such row formats as delimited or regex CRD. So now I'm going to uncover the power of file formats containers and row-column oriented file formats in particular. To the best of my knowledge, Facebook was one of the first companies who experimented with row-column oriented files. They published an article about record-columnar file formats in 2011 named RC-File, a fast and space-efficient data placement structure in Mapreduce-based warehouse systems. Later on, it went to public as an open-source project. It was designed for fast data loading. Already in 2011, Facebook generated more than 20 terabytes of data per day. Fast query processing. Data stored in Facebook Warehouse was simultaneously processed by concurrent users. Highly efficient storage space utilization. Quite an obvious requirement, if you ask me. Strong adaptivity to highly dynamic workload patterns. In Facebook, they did not find any regular data processing patterns. There was the majority of unpredictable ad hoc queries. RC-File was widely adopted by Hive and Peak in Facebook and Yahoo. So how did they manage to achieve all of these goals? All genius ideas are really simple, and this one is not an exception. The logical table is divided into row splits. And then, instead of storing row split sequentially reading from left to right and from top to bottom, you store your data by columns, in other words, reading from top to bottom, from left to right. You may ask, what is different? From user's perspective point of view, nothing. But from the framework optimization point of view, you have found the holy grail. Take a look at the following example. You have columns which are numeric, strings, or dates. Let me structure them column by column for you. If you implemented a framework to store this data, how would you decrease disk space requirements taking into consideration the aforementioned data layout? For example, you can use lossless compression techniques. Compression applied to row-oriented file formats does not provide so much benefit compared to compressed column-oriented file formats, because you can use different compression algorithms to different data types. Consider datetimes. They are usually stored in the form of Unix timestamp. Unix timestamp is a number of seconds since the 1st January 1970. This date is an official starting point of Unix epoch. For example, the value of 1.5 billion Unix seconds is 14th of July 2017. If you store these dates in a plain string format, then each date consumes 10 bytes per date. If you store them in integer format, then each date consumes 4 bytes. The upper limit date in 4 bytes format is the beginning of 2038. So be careful with this representation. For storing timestamps, there is a better space-efficient way which is used in an optimized version of RC-File format. Have you heard anything about delta encoding? Instead of storing plain timestamps, you store the first value and all others are stored as delta values to the previous timestamp. How many bytes you need for delta encoding highly depends on your data, but usually 1 byte of data per value is enough. The more you know about your data, the better you can compress it. String data types are dictionary encoded and other numeric values are run length encoded. I only highlighted the basic concept to give you an intuition. If you are curious to learn more on RC-File implementations details and compression algorithms, please follow the provided links. Turn back to our design goals. Fast query processing, yes. You can easily skip the whole columns if you don't need to read them. Efficient space storage utilization. Definitely yes. You have seen how you can reduce storage space usage by almost a factor of magnitude. Fast data loading. According to Facebook experiments, RC file requires extra 10% to group and compress records. But mostly you live in write once, read many paradigm in big data world. Speed up of query execution time dramatically outperforms shortcomings in data loading. Dynamic workload adaptivity. It was achieved by the next generation of RC file format, which I encourage you to use nowadays. It is called ORC, ORC for short, which stands for Optimized Row-Columnar File Format. It was a joint work of Facebook and Hortonworks. At the same time, Cloudera and Twitter developed Parquet file format pursuing similar goals. In Hive, you can use both of them. ORC file format also contains index information about minimum, maximum values in a column stripe. It will give you a power to skip the whole stripes of data during query analysis, so you don't need to read and decode this data. More about predicate pushdown you will learn during the last week of this course. ORC also contains information about count and sum, and therefore a bunch of aggregate queries can be highly optimized for execution. And there are a lot more tiny tricks implemented to make your warehouse fast and efficient. So it's time to see how to use ORC files in practice. Here is the way to define a Hive table with ORC data file layout. You can provide configuration parameters via table properties statement. On the slide, I only provided a few of them. Hive table metadata, such as ORC file configuration, makes sense only for data reading and writing. It is already a significant improvement over the row-oriented file formats. But Hive queries usually consist of number of Mapreduce jobs. Therefore, you have to take care of disk I/O usage between Mapreduce stages. Compression in between is controlled by the following Hive configuration parameters. The first flag is used to set intermediate compression. Then, if you use Mapreduce execution engine, you can configure compression between map and reduce with provided flags. Other execution engines supported by Hive are Apache Spark and Apache Tez. Most likely you will use them in production environment, so you know where to look for optimization options. In this video you have learned what are the components to build efficient row-column oriented file format for big data applications without any regular workload patterns. You know how to use ORC and Parquet file formats in Hive tables. And please, don't forget about intermediate compression. Take my word for it. Data layout, including data partitioning, bucketing, and file format configuration, are essential components in Hadoop ecosystem. I remember the time I was working at Rambler and managed to reduce the time to run business-critical pipelines from days to hours, just with the help of proper data layout configuration. And I bet this knowledge will help you to optimize a lot of data processing pipelines in your career.